what we have learned is whether limit exists or whether the function at that point is defined or not defined, and how do we find limit, and how do we say limit is defined or not defined. We know if there's a jump, the limit doesn't exist. If there's like to infinity or negative infinity, the limit doesn't exist. And to define the requirement is easy. To be defined, you just need the value, like got a value for that x values. Okay, so now what we're going to learn is continuity. Okay, whether the function is continuous at that point or not. Okay, so I have like theory. Okay, in theory you need to check three things. But if on the graph you want to say if you want to say whether it's continuous or not, you only need to see whether the graph is connected at that point is enough, okay? If the graph is connected at that point, then it is continuous at that point. If the graph is not connected at that point, for example, like that, then it's not defined at that point. It's not connected. There's a jump, or like there's a gap, or there's a open circle, they're not connected. Then if it's not connected, which means it's not continuous at that point. Okay, so let's first of all think about what's the theory. Okay, in theory, what we can say, like you can't really, okay, tell me the reason why this graph is not continuous. You can't say because the graph is not connected. Okay, you need to talk about the three things here and to talk about which one is not followed. Okay, which one failed. So number one, you must have the fx is defined at that point A. If it's not defined, it can't be continuous for sure. Okay? If it's not defined, it cannot be continuous for sure. And the second thing, the limit must exist. Okay? The limit must exist. If there's no limit, which means it can't be continuous for sure. And the third thing is, it's not enough. You both have the limit exist and it is defined. And you need those two values to be equal as well. Okay? If those two values not equal, it's not continuous. So that's the three things. And I give you three examples which is not continuous at a single point. And it's not satisfy one of those rules. Okay, it's not satisfy one of those rules. Shh. Okay, so let's see the first one. First one, let's see at x equals to 0. You can see there's an open circle. You can see that it's not connected at that point. So what you need to write is f0 is not defined. Okay, f0 is not defined. So at x equals to 0, not continuous. Okay, it is not continuous at that point. Because first it's not defined already, you don't need to talk about other things. The limit does exist. Can you see the limit does exist, but it's not defined, so it's not continuous. Okay, for the second one, see the f0. f0 equals to 0, so it is defined. Okay, it is defined. But the limit x approaching to 0, fx not exist. Okay, it's not exist because from the left you're approaching to 0, from the right you're approaching to 1, so left limit and right limit are not the same, so it's not continuous. Okay, first one satisfied, but the second one doesn't satisfy, so at x equals to 0, not continuous. Okay, it's not continuous. Okay, the third one is actually quite interesting. Okay, the third one is quite interesting. I put this example here because you may can't understand why number 3 needs to be here. Oh, your limit must always equals to f0. Why I put that one here? Let's look at what is f0. Can you see there's an open circle here, but there's a red dot on the top. So you have 1, 2, 3, 4, 5. So f0 equals to 3. Okay, it is defined. Is this red dot here? Okay, fx equals to 3. But the limit x approaching to 0, fx equals to 1. Because from the left, you go along this graph and you go towards this point. From the right, you go towards from this point and go towards this point. So it's 1, it's not 3, okay? You're not approaching 3. The limit is actually approaching to 1. The closer you get to 0, the more closer y value approaching to 1 you get. So therefore, f0 is not equivalent to lim x approaching to 0, f0. So it failed this one. So at x equals to 0, not continuous. Okay, it's not continuous at x equals to 0. So, okay, the first one failed number 1, the second one failed number 2, the third one failed number 3. I give you all counter examples for those 3 rules, 3 series. So it needs to be satisfied at the same time, then it is continuous. Or you can see all of the 3 graphs on the graph, they are not connected. Okay, they are not connected. There's a hole or a jump, like, or a gap, so it's not continuous. Okay, example 3. Talk about the continuity of the functions. Okay, talk about the continuity for these functions. So if, let's say, girls, stop talking, please. If the graph is not continuous, which will be like the problem point? Which point will be like possibly to have some problem? 2, okay? It's the connection point. All the other part is correct, okay? It's like a linear, okay? We have a linear, and we have a quadratic. They're all connected anywhere, except the connection point between the 2 graphs. So the point 2 will be a problem point, okay? To be a problem point. So what do I mean by connected? When they have the same x value, they have also the same y value, which means connected. They are overlapped at that point and it's connected. Let's call the top function f1x. That is x belongs to 0 to 2. Let's call function f2x for the bottom one. And that gives you x belongs to open circle 2 to 6. Okay, the 2 is the problem point. So you will think about 2. Okay, so let's say what is f1 of 2? f1 of 2 is 2 minus 2, which will give you 0. So what is f22? Okay, this is a closed circle. Okay, that will be a closed circle because you can take the point 2, so it's a closed dot. But for f22, you substitute 2 in. You have 0 as well, but that will be an open circle. Okay, it will be an open circle. But a closed circle and open circle will become a closed circle, and which means the point is connected, okay? At the same x, you have same y value, which means the graph is connected. At x equals to 2, okay? Which means everywhere is alright, okay? Nothing is like there's a jump or a hole like that. So you say for x belongs to 0 to 6, the graph is continuous anywhere. Okay, the graph is continuous anywhere because the only problem may occur at the connection point, and you have proof that the connection point got no problem. So it's continuous anywhere. Okay, that's how you test about the continuity. And let's talk about the continuity for the second one. So again, let's make f1x equals to 2x and f2x equals to x squared minus 9. And you can see the connection point is 3. Okay, you can see the connection point is 3. So you put f1 3 in. So it's 2 times 3 equals to 6. f2 3 will equals to 3 squared minus 9. That will give you 0. So this one will give you a closed circle. And this one will give you an open circle. But they're not at the same point because you have 3, 0 is an open circle. And you have 1, 2, 3, 3, 6, which is a closed circle. Wait, 3, 0. Here is an open circle. And here is a closed circle. There's a jump. Okay, there's a jump. That is 3, 0, and that is 3, 6. So it's not connected at that point. Okay, I don't care what my graph looks like later. Okay, I don't care what the graph looks like later. But there's a jump. So you will say the graph is continuous anywhere else except x equals to 3. So the for x belongs to, where's the domain? From -3 to 6. Okay, the graph is continuous anywhere else except x equals to 3. At that point, it's not connected. Okay, you're trying to connect the two graphs but failed. So you say it's continuous anywhere else except x equals to 3. Okay, now we are going to talk about what's the derivative. Okay, what's the derivative? I don't want to go through all the things there. Okay, so tell me what's the derivative. Derivative is finding the gradient for a function. And how we can find the derivative? We use the first principle to find the derivative. Even though we have all the rules for derivative, but it's all coming from first principle. Okay, every rule you using is coming from first principle. So there will be some particular questions just ask you use first principle to show something. So you need to know how to use first principle. So what is first principle? The first principle is this thing. Okay, if you see the question ask you to use first principle, if you don't know what to do, just write this equation there. You may get 1 mark. Okay, so I'll tell you what to do. That's first principle. If they mention first principle, that is the first principle. If you don't know what to do, write that onto the paper. Okay, so why like this first principle, like how we can use this first principle, why the first principle is true. So let's say we have a function, that's a bad function, we have a function fx like this. And then we want to find the gradient for a point. Okay, a gradient for a point. Let's suppose we have 2 points first. Okay, we have those 2 points. And how do we find the gradient between the 2 points? Which is y2 minus y1 over x2 minus x1, correct? So if that point is x, comma fx, and if that point is x plus h, okay, you go right for h units, and this is fx plus h. Okay, I have 2 coordinates. Okay, you go like x go cross by h units. And you find in the gradient, so it's y2 minus y1. So what is y2? Y2 is fx plus h, is the y value. What is y1? It is fx. So what is the change in x? What is the run? Run is h. So that is the gradient between the 2 points. But think about if the 2 points get closer to each other, it get really close, like almost 0. There's almost no distance between the 2 points. That will exactly be the gradient for the x. Okay? Can you think about that? If you go really slow, like really close to that point. So which means you want limit h approaching to 0, and you solve for that. You want to find h is approaching to 0, and then you want to see what's the gradient between the 2 points, and that value will be the true gradient for the f dash x. Okay, so f dash x will equal to that. So I don't want to explain more on that. You just remember them. Okay, remember them. So if we have lim h approaching to 0, and you also have 3, that is just 3 because it's a constant, it's not changing with the h changes. And if you have 3x, but you h approaching to 0, that is still 3x because it's not changing when the h is changing. There's no variable for h, so it's still 3x. And you have this one. this one, there's no denominator, okay? The denominator not h, so you just sub h equals to 0. So h0, h0, what you have is 2x squared minus 3x. Okay, you put h equals to 0 in. For this one, you have h as denominator, and which is not very good if you directly substitute them. You can't have denominator 0, so we need to simplify. So you have 3x squared plus 4. Okay, h and h should cancel, and what you have is 3x squared plus 4. There's no h involved. Okay, there's no h involved, so we need to simplify that. Okay, let's have a look at this one. So for the curve with equation fx equals to x squared minus 2x, find the gradient of the chord PQ, where P is the point at 3. So the point at 3 is here. Okay, let's label that point. That point is 3. So 3 what? What f3 equals to? 3 times 3 is 9 minus 6, which is 3. So you have 3, 3. And then you have another point. Q is a point, that's P, and Q is a point at x equals to 3 plus h. Let's suppose this Q is here. You don't know where is the Q. It depends on the h value. So let's say that's Q. You have x value is 3 plus h. Then the y value must be f3 plus h. Okay, that's the coordinates for Q. And what is the gradient between P and Q? Basically, you just finding the, like, draw a straight line. Okay, draw a straight line and you find the gradient for that line. So how do you find the gradient for a straight line? It's y2 minus y1 over x2 minus x1. Okay, y2 minus y1 over x2 minus x1. So what you will have is f3 plus h minus 3 over 3 plus h x2 minus x1. Okay, y2, y1, x2, x1. So what is f3 plus h? What is f3 plus h? So f3 plus h equals to 3 plus h squared minus 2 brackets 3 plus h. You have, what do you have? That's 9 plus h squared plus 6h minus 6 minus 2h. Okay, simplify that a little bit. You will have h squared plus 4h plus 3. Okay, that's what you have. So let's substitute that in. You will have h squared plus 4h plus 3, and you have the minus 3. You have h at the bottom, so that is h 4 plus h. Okay, 3 and 3 cancelled, and you have 4 plus h. Okay, 4 plus h. So that's the gradient for the PQ, okay, for in between P and Q. The larger the h, the larger the gradient. The smaller the h, the smaller the gradient. Okay? So find the gradient of the curve at PQ when h equals to 0.1. So when h equals to 0.1, 4 plus h equals to 4.1. So the gradient for PQ will be 4.1. Okay, the gradient of PQ is 4.1. If h is 0.1, then the gradient will be 4.1. Okay, hence, find the gradient of the curve at P. Okay, find the gradient of the at the point P. So P will be f dash 3, right? What I'm trying to find is f dash 3 because it's the gradient at x equals to 3. I'm going to find the gradient. Gradient is the derivative, and derivative at the point is 3. P is 3, 3. So I'm going to looking for what is f dash 3. Okay, by using first principle, there's another good thing for like first principle is I can change x to any value. So I want to work for f dash 3, right? I want to work for f dash 3. That will equals to lim h approaching to 0 for f3 plus h minus f3 over h. Okay, so what's the normal first principle? The normal first principle is f dash x equals to lim h approaching to 0, fx plus h minus fx over h. Okay, that's the normal first principle. And if I want to directly use first principle to find the value at a point, I can directly change all of these x to a number. Okay, change all of those x to a number. So I change all of that to 3 because I want to find the gradient at x equals to 3. Okay, why I use that way? Because what is this? What is this? That is just h plus 4. Can you see that? Because, what's that? That is f3. Okay? f3 plus h minus f3 over h. So I already simplified that at the very beginning. So that equals to lim h approaching to 0, 4 plus h. And what that equals to? That equals to 4. Okay, that equals to 4. Okay, using the first principles to find the gradient of fx at any point of x. Okay, that's the, I will only show you this example for using first principle. I'm not going to show the rest because you can use the same method to do all of them. So it's waste of time. I'll leave it to you to do by yourself and I'll upload the answer for you. Okay, so first principle. Can you see the word first principle? As soon as you see it, what you will do, you will repeat the formula. I'm serious, okay? Like that's exactly what you will do. Okay, you need to remember this formula. This is not on the formula sheet, I think. So you will repeat this. Okay, that's your first principle. So what is fx? What is fx? Fx is x squared minus 2x. Okay, let's simplify it. Lim h approaching to 0. Okay, fx plus h. X plus h squared minus 2 bracket x plus h. Finish the bracket. And minus fx. Fx is x squared minus 2x. And the whole thing over h. Can you see this? The formula doesn't change. The only thing changes the rule. The rule for f change. Okay? So you just change the rule and put x plus h into the rule. And what you will have is x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x over h. You need to expand all of them. Why I can't substitute h equals to 0 in? Because the denominator is 0. Okay, so I need to simplify first. So this 2x and this 2x cancelled. That x squared and that x squared cancelled. What has been left is lim h approaching to 0. Okay, 2x over h divided by h, you have 2x. H squared over h, you have h minus 2h over h is 2. So that will equivalent to, okay, put h at 0, so you have 2x minus 2. Okay, f dash x should equals to 2x plus 2. So f dash x equals to 2x minus 2, not plus 2. 2x minus 2 by using the first principle. Hence, find the gradient of the tangent. Okay, So what's the gradient of the tangent is f dash x, okay? F dash x is the gradient of the tangent. So you're looking for f dash x at x equals to 3. So basically you find f dash 3, and that gives you 2 times 3 minus 2 equals to 4. Remember, this 4 is what you find for part C, and your answer is correct. Okay, your answer is correct. Part C, you have f dash 3 equals to 4 by using the first principle. And now you prove that is correct. And also at x equals to a, so it's 2a minus 2. It's 2a minus 2. Okay, find the coordinates of the point on the curve at which the gradient of the tangent, so what's the gradient of the tangent? Again, it's f dash x equals to 0. So what you want to do is f dash x equals to 0, which is 2x minus 2 equals to 0, then x equals to 1. And it's not finished because I want to working for gradient coordinates. Then I need to find f1. So what is f1? Is 1 squared minus 2 times 1, which gives me negative 1. So 1 negative 1 will have gradient of 0. Okay, 1 negative 1 will have gradient of 0. And that's a quadratic. This point needs to be the turning point. Okay, the turning point has gradient of 0. The turning point has gradient of 0. Okay, so what is first principle? The first principle will be write what happens f dash x equals to the formula and put the things in, and the next step will be expansion. Okay, you always need to do expansion. Expand and cancel between terms. And the last thing will be divide by h, simplify. Okay, you need to expand. Okay, the expansion is important because if you don't expand, you cannot really find out the values. Okay, if you not expand, you can't really find values. So I'm not going to do example 3. I'll give this to you to try. And the rule for differentiation. So what we have to learn last year, only one thing. Okay, only one thing. What we learned last year is how to derive polynomials. So maybe not polynomials, it's x to the power of n. Okay, x to the power of n. So if you have x to the power of n, n belongs to R. Okay, n can be any number. N belongs to R. So fx equals to x to the power of n. N belongs to R. What is f dash x? F dash x is n times x n minus 1. You times the power in the front and the power will be reduced by 1. Okay, the book introduced this in 3 exercises, which is really funny. They introduced that is a positive integers, okay, for n. And they introduced it's a negative integers, y is still applied. And they introduced it's a rational number, like a fraction or like 0.1, 0.2, y is applied. This is not like really important to teach them individually in 3 exercises. They are only one thing and they follow one rule, which the rule is x to the power of n, and if you try to differentiate that, you have n times x to the power of n minus 1. Okay, one thing. Okay, only one thing. Do not think about a negative, positive, a half, 0.2, root 2. Okay, if there's a number power, everything will be the same. But remember, do not confuse with x to the power of n and 2 to the power of x. That is an exponential. That is exponential. So if fx equals to that, f dash x is not equals to x times 2 to the power of x minus 1. Okay, so do not create your rule. It must be the power is a number, and you can use that rule. Your power is x, you cannot use that. That's exponential. You can't use that. Okay, that is wrong. We will learn exponential differentiation later. Okay, we will learn that later. So we don't have that. Okay, I'll just do B, okay? I just do 1 to tell you what to do. So the differentiation for constant is 0, okay? The differentiation for constant is 0. But remember, do not directly write what is the differentiation. You need to write f dash x equals to what? Okay, you need to write f, because I know a lot of students, they are doing things too quick and they directly start, okay, that equals to that times that plus that times that. Okay, that's fx, okay? You need to have f dash x, okay? You need to have f dash x. So okay, the constant will still remainder, okay? 5 over 8 is still there, doesn't really need to do anything to that. And you times the power and reduce the power by 1. The 3 over 4 is still there, you times the power and you reduce the power by 1. So what you will have for f dash x will be minus 5 over 8, 5 over 2 x cubed plus 9 over 4x squared. That is f dash x. Let's have a look at part C. You don't have fx now, you have y and x. So the derivative representation will be dy over dx. Okay, will be dy over dx. You can't write f dash x because there's no fx. What is fx? So it will be dy over dx. That is same as f dash x. So tell me, can I do 1 times 2? Can I do that? You can't differentiate them separately and times them. You need to use the product rule, which we haven't really learned last year. But what you can do for that one is to expand them. Okay, you have 2x squared plus 4x minus 3x, you have plus x and minus 6. So you need to expand that and then differentiate that. So you here will have 4x minus plus 1. It will be 4x plus 1. You can't directly differentiate and times the answer together. Similarly, you can't differentiate them first and then divide them. You need to use the quotient rule, what we will learn later, like in the course. So now let's have a look at this. So how about if you have things under the denominator? What you will do is you put that back into the power form. And who cares what constant is that? So it's just a constant, okay? So I don't really want to do anything to that. So dy over dx will be 2 times minus a half times x to the power of minus a half subtract by 1. So that is minus x minus 3 on 2. You can keep your answer like that. Or if you want a positive number, power, you have minus 1 over x to the power of 3 over 2. Or you can put the minus outside. Okay, so for this one, what you can do to this one is of fx over gx. So as I said, you can't differentiate them separately and then divide the answer. So you need to rewrite that. So what is that? That will be 2t over 3 over 4t to the power of 2 on 3. Okay, the bottom is t to the power of 2 on 3. And plus 3t over 4t to the power of 2 on 3. And minus 1 over 4t to the power of 2 on 3. So that will be a half. Okay, I always separate the coefficient and the variables. Okay, I never put t on the numerator. So a half t, that's 3 minus 2 on 3. Okay, 3 minus 2 on 3, that will be a 7 over 3. So 3 minus you divide that to the same base, you subtract the power. The same base, you subtract the power. Plus 3 over 4t. Okay, here is 1 subtract 2 on 3, which is 1 on 3. And minus a quarter t to the power of negative 2 on 3. Okay, t to the power of negative 2 on 3. Because it's on the bottom, so flip it, put it on top, it will be minus of that. Now you can find the differentiation. So it's dz over dt, which will give you a half times 7 over 3 t 7 over 3 minus 1 plus 3 over 4 times a third times t to the power of a third subtract by 1 minus a quarter times minus 2 on 3 t to the power of negative 2 on 3 minus 1. So what do we have? That is 7 on 6 t to the power of 4 on 3 plus a quarter t to the power of negative 2 on 3 plus 1 on 6. Okay, cancel that 2. 1 on 6 t to the power of negative 5 on 3. Okay, have a look at the f. I put f there because the notation is a little bit strange to you, maybe a little bit strange to you. So, what is really talking about? Okay, let's have a look at this. If I say that's y equals to 3x cubed minus 4 over x plus 1. So you want to d that dx. So that will be the same as d dx of y. Okay, so that is y, right? That is y. So what is that? That is dy over dx. So it's asking you to find the derivative of that. Okay, this notation means it's asking you to find the derivative of the things inside. And it's already in the derivative notation. It's already in the derivative notation. So you will directly start to write that equals to, okay, that's 4 on x is 4 times x to the power of negative 1. So you directly have that is 9x to the power of 2 plus 4x to the power of negative 1, and the plus 1 just becomes 0. So that equals to that. You directly equals to that. So that is means the whole notation means that's the derivative of the things in the bracket. Okay, the derivative of the thing in the bracket. Okay, that's just some examples here, and I really get bored to do all of that again. Okay, so I will skip all of that. I'll ask you to do all of that by yourself. Example 2, example 3, because you have the coming weekend. So you can do all of that. Again, you will have, okay, see how stupid that, like the negative integers, like, sorry, I really don't like the book. So, you will have like negative integers. Well, like I just put that as some practice. So you have more practice here, and you also will practice on 2 first principles, and you will work on that. It's all your weekend homework, okay? Weekend homework. And then again, C9F is differentiation of rational powers. Okay, what is rational powers? Is x to the power 4 on 5. We have done that a lot already, okay, for the previous examples. So I don't care what are they, you just do it by yourself. But a little bit different is, okay, can't do 2 questions. You can't do this one, and you can't do this one, because you haven't really learned chain rules yet. You can't expand that. So you need to use chain rule, but I haven't really tell you what is chain rule yet. So you can't do those 2. Let's just circle those 2 out, and Yeah, the next one is chain rule, so we will talk about that later. So those two will use chain rule. Because why I can do for this one? Because I know how to expand it. I know how to expand a minus b squared. But if there's a cube root, I don't know how to get out of this. What that equals to is x plus x squared to the power of a third. I don't know how to separate them. Okay, the power is there and I can't get the function out of the cube root. So I need to use chain rule. So what is chain rule? What is chain rule? So chain rule is, okay, you want to differentiate the composite function. Okay, good. We have learned composite function for year 12. It's so hard to explain year 11. And now I can explain that. It's when you want to differentiate composite functions. You put one function into another function and you want to differentiate the combination of them. You need to use chain rule. So, for example, I want to differentiate that. Can you see that's a composite function? Can you see that's a composite function? If I make ux equals to 3x squared plus 1, then if I make u, let's say not ux, let's make u equals to that. So what y equals to? Y equals to u to the power of 3. And what is this? This is, you put u into y, right? You put ux into yx. You put u into y. So I want to differentiate that. So what's the derivative of that? The derivative of that will be dy over dx. Okay, the derivative is dy over dx. But can you see, like, there's a connection thing which is called the u. Okay, there's a connection thing which is called u. So I don't have directly relationship connections between y and x. So y get connections with u and u get connection with x. So what I may say will be dy du times du dx. It's like a canceling thing. Can you see you can cancel those two, that becomes du dy dx. But like, in order to write this is in order to work out what is dy dx. When I know the relationship between y and u and y and x, or u and x. Okay, so I don't have direct relationship between y and x, so I need a intermediate step, which is the u. So I know what is the relationship between y and u. I know what is the relationship between u and x. So I'll times them together. That will give me dy dx. So what is dy du? dy du will become 3 times u squared. Okay, dy du, which is 3 times u squared. What is du dx? Du dx is that one, which is 6x. So dy du is 3 times u squared times du dx, which is 6x. That will be 18x times u squared. What is u? U is that. It's 3x squared plus 1. U squared. So it's 18x times 3x squared plus 1 squared. Okay, that's the idea. Okay, that's the idea. That's how you really find out things. But you don't want to, okay, think about, that is u. I will write ux and I will write du, I will write dy, and I will write all of that and go through that again and again. So there will be some shortcuts, and you directly memorize the formula and apply the formula. So there are two formulas. Okay, there are two formulas for chain rule. So the first one, which is the most useful one, will be if fx equals to gx to the power of n. Okay, you have something and the whole function is to the power of n. Okay, a half or a third. What is f dash x? The f dash x will be very similar to what you're trying to differentiate for x to the power of n. So you have gx to the power of n, you bring the power down. Okay, you bring the power down. You will reduce the power by 1. Okay, you reduce the power by 1. But you need to do one extra thing. The extra thing you do is differentiate the function inside. Okay, 3 stage. Times the power, reduce the power by 1, and differentiate the things inside. Differentiate the function inside. Okay, that's how you can use chain rule. I can prove this for you by using chain rule, but I don't want to. Okay, so I can, like, it's not hard at all. But like, why ask you to remember that? Maybe it's good to know, because I think some questions ask you to show by using show the chain rule. So let's say we have fx, let's say we have y equals to gx to the power of n. Then let's make u equals to gx. Then y will equals to u to the power of n. What you want to looking for is dy dx. That will equals to dy over du times du over dx. So what is dy over du? Dy over du will be n times u to the power of n minus 1. What is u? U is gx, so it's n times gx to the power of n minus 1. What is du dx? Du dx, which is derivative of this, so it's g dash x. Okay, you derive that, so which is g dash x. Okay, so it's coming from here. You derive that will be g dash x. So let's put the things back. Dy du will be n times gx to the power of n minus 1 times du dx, which is g dash x. Okay, I have proved that. But you don't really need to go through that every time. You just need to remember, I'll jack the power down, reduce the power by 1, and I will differentiate the function inside. Okay, I'll differentiate the function inside. So let's go back. Let's go back to this question here. So we have that. Okay, let's say y equals to that. Y equals to that a third. So that's gx to the power of a third. Your gx to the power of a third. So what you will do is dy dx will equals to a third, drag the power down, reduce the power by 1. You can reduce the power by 1 and derive whatever you have inside. You have 1 plus 2x. So what you have is a third, 1 plus, so 2x plus 1, and times x plus x to the power of 2 to the power of negative 2/3. Okay, that's how we use chain rule. Now we have another one here. That is y equals to 1 plus x squared to the power of negative a half. The power is negative a half. Then dy dx will equals to drag the power down and reduce the power by 1, which is negative 3/2. And then derive whatever you have inside is 0 plus 2x. So that it gives me minus x over, that's a negative, so it's 1 plus x squared over 3/2. You have that. Negative a half times 2x, you have negative x, and that's a fraction is 1 over that, so it's negative x over that. That's the first important formula for chain rule. Okay, the first important formula for chain rule. Okay, the second important formula for chain rule will be, I have no place to write it. I'll write it on the previous page. So the first one gives you fx equals to g bracket x to the power of n. F dash x will gives you n times g dash x, and then you still have gx to the power of n minus 1. Okay, this is the first chain rule formula, which is important. The second important chain rule formula will be y equals to f gx. Okay, put one function into another function, and I don't really know what are those functions, and I can't really tell what are the functions. The function is not to the power of n. Okay, it can be put log into quadratic, put cube root into the exponential, like things like that. So it's not a simple power combination. So what that will be? So dy dx, which means the derivative will be, okay, you drag the inside function out and you derive the inside function. And you derive the outside function, and you will still have it whatever you have inside. So it's g dash x times f dash gx. So what that means, let's say we have y equals to, what I can have, 1 over x squared plus 1. Okay, let's say we have that. We can say that fx is 1 on x, okay, and gx equals to x squared plus 1. So f bracket gx will equals to 1 over x squared plus 1. Okay, now you want to find dy dx. Okay, you want to find dy dx. So what is dy dx? Dy dx will equals to g dash x f dash gx. Okay, let's have a look at what is f g dash x. G dash x will be 2x. Right? G dash x will be 2x. Gx is that, g dash x will be 2x. So what is f dash x? That is x to the power of negative 1. So what is f dash x? F dash x is minus x to the power of negative 2. That equals to negative 1 over x to the power of 2. And what you want is f dash gx. So what is f dash of gx? So you put gx into f dash x. So is minus 1 over. Okay, this x will be replaced to gx. So gx is x squared plus 1, the whole thing squared. Okay, f dash x is this, gx is this. So what is f dash gx? You put gx into f dash x, and that will give you minus 1 on bracket x squared plus 1, the whole thing squared. So what is dy dx? Dy dx is g dash x, which is 2x, times f dash gx, okay, is this. Minus 1 over x squared plus 1, whole thing squared. Okay, so that's the derivative. That's the second important formula. I'll tell you, okay, it's normally not working questions for this type. It's working for some other type of questions. I just want to show you an example because you haven't really learned sine, log, those kind of derivatives. I can only show you the simple one. But the idea for this one will be the same. So dy dx will be equal to g dash x f dash of gx. So two important formulas here. You must remember them. Okay, they are very important. Okay, you must remember them. Okay. Then the rest will be using this. I'll show you the example 3. Okay, I'll show you the last example, which is not hard. It's quite fun. So you have hx equals to f bracket gx. Okay, you want to work for h2. So what H2 equals to? H2 will equals to F bracket of G2. Okay, so what is G2? Can you see what is G2? Let's look at here. G is here, 2 is here, G2 will be 1. Okay, G2 give you 1. So G2 is 1. And then you're looking for F1. So what is F1? F is here, 1 is here, F1 is minus 2. So H2 gives you minus 2. Okay, H2 gives you minus 2. You're using this table to find the values. Okay, now you want to work on H-1. H-1. So before you want to work for H-1, you need to know what is H-x is. So what is H-x? Okay, can you see this function f gx? So you will have the inside function, you derive the inside function, you derive the outside function, and you still put the inside function in this one. So that is H-x. So what is H-1? H-1 will be G-1, F dash bracket G bracket 1. Okay, put 1 into here and here. So H-1 will equals to, what is G-1? G-1 gives you negative 2. Okay, F dash bracket, what is G1? G1 is here, 0. Okay, have F dash 0. So what is F dash 0? F dash 0 is minus 3. So you times them together give you 6. So H dash 1 is 6. Okay, so the second formula is actually to use for this type of question. Okay, to use this type of question.